Another day, another DSA problem. So today we're going to look at 3756, concatenate non-zero digits and multiply by sum. This is the second part of this problem. So yesterday's problem was the easy version of it. And that solution will not work here. It's going to give a TLE. So let's just look at today's problem and let's see how we're going to go ahead with it. Okay, I'll just jump over to my iPad. I think it's better I explain here directly. Okay. So the problem states that we are given a string S consisting of digits. So we're going to be given a bunch of queries, and each query is going to look like this. It's going to be an L and an R index. And what we're basically asked for, the goal is for each of these queries, we want to take the substring, which is from S of L to R. We want to remove all of the zeros. And then we want to form a number, X, by concatenating all of the digits, like the ones which are not zero. And then we want to have a digit sum, which is going to be a sum of all these non-zero digits. And eventually, for this query, we want to return the value of X, which was the concatenated number itself, excluding the zeros, and also the sum of it. And then we just want to mod this by this number over here and return that. So let's look at an example. Let's say this is my string. I've just written it out like a list over here so we can actually check the index values and understand better. But yeah, it's essentially going to be a string of numbers. So this is the number 100320910. Now let's say one of our queries is giving us this 1 and 6. So we have L is equal to 1 and then R is equal to 6. So that's essentially from here to here, right? So let's just write that down. So this actual value is going to be 003209 from index 1 to index 6. All right, so what they've told us is that the value X will be whatever that substring was, removing all of the zeros. So if I remove the zeros, it's going to be 329. Okay, and then the digit sum of this is basically 3 plus 2 plus 9. And what is that? That's 5 plus 9, which is equal to 14. And the answer is basically going to be equal to 329 into 14. I don't know what that is, but yeah, this is what we're supposed to return. And this is for every single query, right? So this is just one query that we took an example. There are going to be, let's say, M number of queries, right? So let's consider that the length of the whole string is length of S. We'll take that as N. And then we're going to have M queries, right? So we're going to be doing M into N over here, basically. But let's just see the brute force how we would do it, right? So what we want to do, we want to take every query, right? And every query on its own is an L and an R, left and right pointer. We want to extract the specific substring, which corresponds to this S of L to R. And then we want to remove the zeros. And after removing the zeros, we want to form that number. So we want to form the X value. And we want to get the digit sum. So basically, it's just going to be sum of all digits in X. And X is the one which is after removing zeros, right? So this would be the brute force approach. And this whole thing would take of whatever length that is, so R minus L plus 1. So basically, it's the length of substring, right? For each query, that would be the length of substring. And yeah, so the length of the substring and then per query. So we were considering that we have like M queries and the length of one substring, let's say, is N. It's going to vary, right? So we're going to do that for each substring. So basically the total time complexity would be a summation of the length of all of these substrings, right? And this is going to give us a time limit exceeded. So we have to think of something which is much more optimal, right? And the question is, can we optimize? And obviously, yes, we can. So there's something worth like noticing in this problem. See, so as I've written over here, so you notice that for many queries, there's gonna be an overlap, which means that we're repeatedly doing or processing some character over and over again. So it comes to the question of why would I want to repeatedly do something when I can just store some value of having done it already and then just use those values, right? So let's just see what a repeated work here will be. So if we have like these index values that I've shown here, and we're going to take a range, L and R, which is 2 to 8, right? And then I have another range, let's say 3 to 7. And then I have another range, which is 1 to 6. You see that there is so much of an overlap, and we're obviously going to be computing those values redundantly over and over again. So we're getting a sense of something over here, right? Let's pre-compute values. Let's try to cache it, something like that, because redundant work, repeated work kind of goes towards the direction of do it once and store it. So here's the intuition. So instead of rebuilding the answer for every single query, can we pre-process the string just once? Can we cache that, the useful information, and then can we use it? Okay. So if we want to translate this into like an actual pattern and approach here, we're going to be doing prefix arrays. Okay. So this is our caching mechanism. Which is gonna allow us to kind of answer this query. Like if we have all the pre-computed values, basically taking a query will be just using that left and right index values, just plugging it into what we already have, accessing those values, using some kind of formula. So that's obviously, it's O of 1. And then if we have M queries, and yeah, so we'll be doing each of those queries in O of 1 time, and then there's going to be the pre-computed work. So this is just M into O of 1, so that'll be O of M, and then our pre-compute work, let's say, because we are kind of handling that against the whole size of the string itself. So we had considered the size of S to be N, right? So that would be O of M plus N, right? So here M is length of queries, yeah. And then N is going to be length of the string S that was given to us. All right, so now we know the what are we going to do part. So let's talk about the how are we going to do it, right? So let's look at an example over here. 102304, this is going to be our string S. And so basically what we need, according to the question, is we need the digit sum, which is going to be the sum of all of those non-zero digits within the given range that we were asked to calculate it for. And then we also need the concatenated number from the same range, removing all of those zeros, right? So these are the two things we need, and then we just need to multiply them and return it back, right? So the first thing, let's look at the digit sum, okay? So the same example, 102304, I've just written this kind of prefix sum table over here so we can follow it. So digit sum is basically easy, right? I just keep telling like, what is the sum up till here? And I keep doing that. And then obviously like this is just basic prefix sum. Then we're gonna take the right and then we're gonna subtract what was there before the left value, right? So either that or just take the next value of the right one because it includes the right and then we subtract the left. We'll just see it over here. Okay, so let's look at the prefix sum for the value of 1. There's nothing before 1, so it's going to start with 0, and then we're going to add 1, right? So the next value would be 1, and then I add this value, which is again, it's 1. And then for the next value, I add this value. So it's going to be 3 when we come till here. Then at this position, it would be 3, like everything before 3 adds up to 3. And now we have 3. So once I cross 3, it'll be 3 plus 3, it'll be 6. And then here till here, everything before that is just 6. And then it's 0, so this will stay 6. And once I cross 4, 4 has been included in my range. So this will add up to 10. So now let's just take an example ranging from 1 to 4, okay? So the fourth value will actually have values which are before the fourth index, right? Before 0, 1, 2, 3, before this value, everything before that. But I also want to include this index value, so I'm going to go to the 5th position here. So that's exactly what's given here, prefix sum of r plus 1 minus prefix sum of L. And L is 1 over here because L obviously stores the sum up till the digit before it. So that's exactly what we want, right? When we want this range, we're going to go to the value which includes the last number, and then the value where like this one, sorry, or that previous number was, we want to kind of eliminate that. Okay, so now we have our formula for this. This is very straightforward. Now the second question comes, how are we going to get the concatenated number? Okay, so this is a little tricky until we really understand what we're going to do. So we want to pre-compute values, and we're going to cache this as well. So let's say this, instead of storing the original digits, let's just store the number that was formed by all the non-zero digits seen so far. Okay, that statement is going to make sense once I take an example and actually show you guys what's happening. Okay, so this will be our example 102304. Okay, so if I want to calculate it for a certain subarray, what I want is a prefix number. And the prefix number is basically going to tell me till here, if I take all of the non-zero digits and I concatenate them, what number do I get? And then the prefix non-zero count is going to tell me how many non-zero digits do I have till here. It's going to basically be the length of this. Okay, so this will make sense once we go further, but let's just calculate this for now. I don't know why I wrote this here. Okay, so an empty string, right? The prefix number is basically, it's nothing. So it's just 0, and the prefix non-zero count is 0. Then I go to the number 1. So if till here I check it, if I remove all the zeros, the number is 1, and the prefix non-zero count is 1 because I have 1 digit. Then I go to 1, 0. Okay, so till here the number is still 1 because that 0 is eliminated. This non-zero count is also 1. Then I go to 1, 0, 2. Okay, the 0 is removed, so this will then become 1, 2, and the non-zero count is 2. 1, 0, 2, 3. 0 is removed. 1, 2, 3, and then till here the length will be 3. Then 1, 0, 2, 3, 0. Again, this will be 1, 2, 3 till here. The length of non-zero numbers, like the count of it, will be 3. And 1, 0, 2, 3, 0, 4. Again, if I remove the zeros, this is going to add up, like this is going to become 1, 2, 3, 4, concatenating those numbers, and the prefix non-zero count will be 4. Now, let's kind of see an example over here, right? So this was S, 1, 0, 2, 3, 0, 4. Our L value is 2 and our R value is 5, right? So if I actually look at S of L to kind of R plus 1 inclusive, this is going to give me, so 0, 1, 2, 3, 4, 5. Okay, 2 to 5, like inclusive, will give me the string 2, 3, 0, 4. Okay, 2, 3, 0, 4. Then I have to remove the zeros, so this is going to be 2, 3, 4. Now, if I ask the question, using the table like the values that I just pre-computed, how can I come to 2, 3, 4? Okay, so now let's look at this. So our right index is 5, right? So we're going to go to, we're actually going to go to the index after that because it has included that. So let's go to this value here, and we'll look at the prefix number that was formed till here, right? So we have this, our prefix number is going to be 1, 2, 3, 4. Now, if you observe this, I have 1, 2, 3, 4, but what I actually want is just 2, 3, 4 because it's going to remove the 0, and it's like 1, 2, 3, 4 was everything from the start, but I don't want this prefix of 1, right? I want to eliminate that. I only want 2, 3, 4. So now there's a really intuitive solution for this. Okay, it's going to be a formula. Now, if you look at 2, 3, 4, the whole number itself is 1234. Now, if I want to make that to 234, I can write it as 1234 minus 1000. So basically this value right here, so if I take this and I actually like multiply it by the 10th power, which it's supposed to be raised to, and I subtract that, I get my answer of 234. And now we'll see how we're going to like correspond that to this table over here. Okay, So I'll write it as 1, 2, 3, 4, which can be written as that number itself. So the prefix of whatever this r plus 1 value is, or just r, let's just say r. And then we're going to subtract that. What we're going to subtract from it is the prefix value of the number before it. So the left value, right? So if L was 2, then I will come here. So 0, 1, 2. So this value. So the prefix number was 1, right? So that's the number I actually want to remove. So this will be 1. And I will raise it to 10 to the power of how many non-zero digits did we have till there? Okay. And this is basically, we're going to store the count of non-zero digits. So I'll also check, like when I came here, the non-zero digits was 4, but before that value, before this, like the non-zero digits was 1. So I'll do 4 minus 1, which is equal to 3. Okay. So it's going to be 1 into 10 raised to 3, which gives us 1,234 minus 1,000, which is going to be 234. Okay, so it's very important to remember the count of the non-zero digits, because if I had just added like all of these digits, then I'd be getting basically like the wrong value. So I need to remember that I'm always just dealing with the like the number which is stripped of all the zeros. Okay, I know this might seem a little confusing, so you guys can probably take like a minute or two to kind of absorb what's happening, and once you get it, it becomes really easy to go forth with this problem. So this is the heart of it. This is the logic that's going to be used to get that number. And the formula for this, as I've written here, so this substring number is going to be equal to the prefix sum of right minus the prefix number, which was at left, multiplied by 10 to the power of how many non-zero digits were there in this range. Okay, so that's it. That gives you your substring number. And it's amazing, because all you have to do is pre-compute these values, and for every query you just plug in those L and R values to this formula, and you just get that in O of 1 time. So that's amazing. And then you had your prefix sum, which was already very straightforward. So let's look at what we've learned here. So the digit sum, which we needed, was basically going to be our vanilla prefix sum formula, right? Prefix sum of right minus prefix sum of left. So it's actually going to be right plus 1, but you guys get that. Yeah. And then we get our substring number, which I mentioned right here, was going to be equal to the prefix number till right, subtracted by the prefix number of left, times whatever 10th power it had to be raised to. Okay, so once you have these two values, all you do is just multiply them, and that itself becomes your answer for that specific query. And you do this across all queries, right? You do this across all queries, and you just put it into like an answer array, and then you return that. So that's basically what this problem is. So let's just look at our time complexity, our complexity analysis, right? So we're calculating the prefix sum, O of n. We're going to calculate the prefix number, which I mentioned, again, O of n, where n is actually the length of s, as I mentioned earlier. Then we're going to calculate the, count the non-zero numbers, right? Again, O of n, we're going to do powers of 10. We'll just do that and store it so that we can use it later. So that's O of n. So this is actually going to be 4n, but constants are dropped. So this is just O of n. And yeah, so this is O of n, which is all our pre-computing work. So this O of n, and then where does O of m come from? So O of m, where m is the number of queries. So yeah, it's the number of queries, and every calculation of it is just going to be m into O of 1. So that's just O of m plus the pre-compute work. So it's O of m plus n, and then the space complexity is O of n, because we're storing all of these prefix values, right? So the prefix values and the powers of 10, so that would actually go to like 4n, but then yeah, we're dropping constants, so O of n. So this is actually really cool, right? Because we went from our brute force approach of where'd it go? Yeah, our brute force approach was actually O of length of all substrings, which would be really big. And now we've just gone to O of m plus n. So yeah, that is a really good solution here. So yeah, I hope you guys understood it. I'm just going to walk through the code. Actually, I'm not going to write it. I think these formulas are just what you plug in to the code. So it's the same thing. Okay, so first thing we'll do, we'll just pre-compute these values f to the power of 10. Okay, so we'll just store that so we can use it later. And yeah, so I mentioned we wanted a prefix sum. We want a prefix number, which is going to store the concatenated non-zero number, which is formed till that very index. Prefix non-zero count is going to be the count of those non-zero numbers till that specific range. And then we're going to go ahead and build these, right? So every time we build it, so digit, again, because s is a string, we want to convert it to an integer. Then prefix sum is basically going to become like, we know what prefix sum is, right? You're just going to take the previous value and then add the digit to it, and you're going to keep doing this. Okay, so there may be situations where there's just a 0. So in that case, I just want to carry forward what value was there before, right? So that's why I'm just filling this in to be the default of what the previous value was. And only if the number is not a 0 am I going to add the contribution of that specific value, okay? So that's what I'm doing here. This will be added 10 times digit, okay, this value, okay? So we're basically forming this number, that's why we're doing this. Prefix zero count is, yeah, you're gonna add 1. So you see here, we're just multiplying 10 and then adding the digit, which is the same thing as we're trying to form that number. Like, you guys understand this, I bet. Okay, so we are going to expand that number. And because it was a string and we need to convert it to an integer, and now we have this value, let's say 23, and then we have another value to append to it, like 4. Okay, so that has to be 23 into 10. So 230 plus 4, 234, yeah, basically. Okay, that's what happens. So after this, we just pre-compute all of these values. And then we're going to hold like an answer array. And I don't know why it's not showing things properly. Let me just refresh it. Okay. Yeah, and then we're going to go fill this answer array. And we're going to go traverse through queries, take a left and right pointer. We'll do right plus is equal to 1 because this makes up for, yeah, you see everything is shifted by 1 here, if you see. So that's why we're just making that more simple here. Then we're going to take the digit sum, which is basically vanilla prefix sum, right minus left, okay? Non-zero digits will be how many non-zero digits were there till this point and how many non-zero digits were there before that range started, okay? So that's what we get here. And now that we have this value, we can actually calculate what this is going to be, like what I mentioned here, 1, 2, 3, 4 minus 1 into 10 raised to 3, right? So the prefix number at the right subtracted by the prefix number from the left, which is the one before that range, multiplied by the 10th power raised to the number of non-zero digits that were there. And just remember to mod everything in this problem, okay? And whatever we get, we're basically going to append that because we want to get that substring number and the digit sum, right? Those are the two things that we calculated eventually. Multiply those, mod it, and we want to append that to answer. And yeah, and then you just return answer. Let me just write the time. Where is this looking? Okay, let's just write the time complexity. It's O of m plus n. And the space complexity is O of n. Okay, let me run this and show you guys. All right, it works. So yeah, I hope you guys understood it. And this has been a pretty long video. That's why I didn't code it up. So anyway, happy coding, everyone.